All right. So before we launch into example 2, let's scroll back up here a minute and look at what we just talked about as far as what a linear function is. A linear function has a constant rate of change and its graph is a straight line. Okay, so here we're given two different functions in tabular form, and we're asked to figure out which, if either of these functions, is linear. Okay, now, it might be tempting to look at this and just look at the difference in the function values as x increases, right? So here it looks like p of x went up by 40, and then let's see, what did that went up by what, 120, and so on. It looks like it's not going up by the same amount for each increment in x. And q of x, well, you can see it's going up, it's going down by 5, down by 5, down by 5, down by 5. Okay, so that might make you think that q of x is linear. But you would be wrong, because you have to be really careful about what is your increment in x. If the increments in x are the same each time, like if this was 10, 20, 30, 40, 50, these increments of x were always the same, then you could do that. You could just look at the difference between consecutive function values. But here we have x values. Once it's going up by 10, it's going up by 30, it's going up by 25, and then it's going up by 125. Okay, so the increments in the x value are not the same each time, so we have to be careful. So we said that a linear function has a constant rate of change. So let's just look at each interval here and look at the average rate of change. Okay, so the first interval we'll just look at between 10 and 20. All right, so I'm going to look at delta p over delta x, and then I'm also going to look at delta q over delta x. But let's look at p first. All right, so if we look at the change, let's over this first interval from 10 to 20, we get 55 minus 15 all over 20 minus, well, I'll just write it out, 20 minus 10. Okay, so that's 40 over 10, so that gives us 4. Okay, so we have a rate of change over that first interval of 4. All right, let's look at delta q over delta x. Do the same thing. We're just going to take the difference in the function values, so that's going to be 35 minus 40, all right, over 20 minus 10. Okay, so you can see that's going to be it's going to be a negative 5 over negative 10, so that's going to be a negative 1/2. Okay, so I'm just going to do that for each interval. All right, so the next one is between 20 and 50. So I'm going to look at delta p over delta x. All right, so I'm going from 175 minus 55 over 50 minus 20. Okay, so you'll see that also gives you 4. So there you go. There's a clue as far as which one is linear, at least so far. You can't always tell based on just two values, though. So let's keep going. All right, so if we look at delta q over delta x, we get 30 minus 35 over 50 minus 20, which gives us negative 1/6. Okay, so you can see already q of x is not linear because we're not getting a constant rate of change. But we need to keep going with with p of x to make sure, because you can't always tell over just two intervals. So let's look at the interval from 50 to 75. So delta p over delta x is equal to, what is it, 275 minus 175 all over, let's see, that goes from 75 minus 50, right? All right, so you plug that in, it looks like you're going to get 100 over 25, which is 4. Okay, now if you look at delta q over delta x, you can do that too. Now you've already determined that it's not linear. If you look at it, you'll end up with a negative 1/5 over that next interval. But we probably could be done with that. All right, so far so good with P. Let's just check this last interval. So 75, look at the interval from 75 to 200. Delta P over delta X. Let's just see what happens. We have, what, 775 minus 275. Okay, so that's a difference of 500 over 125. So it looks like that's also 4 when you put it in your calculator. Okay, so I'm not even going to bother with Q of X because hey, we already know Q of X is done, right? It's not linear. So Q of X is not linear because it does not have a constant rate of change. But P of X appears to be linear. It is linear. All right. So there you go. I'll meet you in the next video.